Hello, this is the solutions video for AP Calculus section 4.2. We're on page 360. We're going to do 1 through 9 odd, 35, and 37. All right, number 1, we want to find the sum of I equals 1 to 5 of 2i plus 1. So that's going to be 2 times 1 plus 1. Right? Start at 1 and plug that in. And then we have 2 times 2 plus 1. Right? And then we go to 2 times 3 plus 1. Then 2 times 4 plus 1. And finally, and of course, what's in parentheses here is the I. We go 1, 2, 3, 4, 5. Going around the horn like that. Plus 2 times 5 plus 1. So that's going to be 3 plus 5 plus 7 plus 9 plus 11. All right, and that is 35. At the end of this, I'll show you how you can do that on your calculator. All right, for number 3, we would have 1 over 0 plus 1 plus 1 over 1 squared, which is 1 plus 1, plus 1 over 2 squared, which is 4 plus 1, plus 1 over 3 squared, which is 9 plus 1, plus 1 over 4 squared, that's 16 plus 1. So that's going to be 1 plus 1/2 plus 1/5 plus 1/10 plus 1 over 17. So I would convert that to decimal, and that's about 1.86. All right, this number 5 is one that gets students quite a bit. C is just a constant. There's nowhere to plug this value for k in. So you're just going around 1, 2, 3, 4. So it just ends up being C plus C plus C plus C, because there's nowhere to plug in there. So it's just a constant, and that equals 4C. I typically work that every year. If you want to know how to put these in your calculator, you would just go to Math, if you have a TI-84, and go down to where you see the summation, all right, which is the 10th one, and you can see where you can put, you can fill in here. So, for example, we would have I, so go to alpha, and I'm going to find the I button. It could be K, but if I equals 1 to 5, we'll do number 1 here, of 2 times I plus 1. And you get 35 there. Okay, so pretty cool that your calculator can handle that. All right, number 7, I'm going to put that into view here so that I don't have to rewrite all that. But we want to come up with the sigma notation of 1 over 3 times 1 plus 1 over 3 times 2 plus 1 over 3 times 3, all the way to 1 over 3 times 9. So we know we're going starting at 1, so the summation of I equals 1, and it could be X, any letter you want to pick, to 9 of just 1 over 3i. And that will do it. That'll, if you go through that, now it'll match what the book has. And then on number 9, bringing that into view, we have 2 times 1/8 plus 3 plus 2 times 2/8. So what's changing is the numerator of the fraction goes all the way to 8. So we're going from 1 to 8. So bracket 2 times I over 8 plus 3. And then you can check it just by going through it and seeing does it match what the book has on number 9. And that does. All right, that does it for the summation problems. Now let's take a look at our 2 Reimann sums. So for these, I like to make a little chart. So we're going to do 35 first. That's at the bottom of page 261. We want to do the upper and the lower sum. So the lower sum would be the left side, and the upper sum would be the right side. And we have y is equal to square root of x for our function. Okay, so 35, we have y is equal to the square root of x. We have 4 rectangles here. And so you can see it goes from 0 to 1. So that would mean the base of each of these 4 rectangles, the width or the base is 0.25 for all of them. And then we're going to start, the first left side is 0. Then the second left side would be 0.25, and then the third would be 0.5, 0.75, like that. So let's just make a chart. Let's call this the lower or left sum. So I like to just do it like this. Our rectangle, we've got 4 of those, so we have 1, 2, 3, 4. The base of each rectangle is 0.25. The height of each rectangle, we're going to use the function. So it's the square root. Our first one would be the square root of 0, because the x value on the far left side is 0. So 0, 0.25, 0.5, 0.75 for those 4 rectangles. Remember, we're using the left side. So this would be our second rectangle, 0.25. All right, and the square root of 0.25 is 0.5. And the square root of 0.5 is 0.707. And the square root of 0.75 is 0.866. Okay, so that is the height of each rectangle. So the area is base times height. So we would have 0.25 times 0 for our first rectangle. That's 0. For the second one, it would be 0.25 times 0.5, right? Base times height. So that'd be 0.125. For our third rectangle, it's 0.25 times 0.707. 0.25 times 0.707. So that is 0.177. And then our last rectangle, base times a height of 0.866. And that is 0.217. And you just add all of those up, and you would get 0.519. So that is the area of this shape. That's our estimate using the left-hand side as the height, or what the book calls a lower sum. Now let's do it with the upper sum. Same thing. So we have rectangle, 1, 2, 3, 4. Our base, still 0.25, all the bases. Okay, the height. If we're going to use the right side as the height, we're starting with x of 0.25, then x of 0.5. Then x is equal to 0.75, and finally when x is equal to 1. So we would take the square root of 0.25 and the square root of 0.5, the square root of 0.75, and then the square root of 1. Well, I've already done this work. Square root of 0.25 is 0.5. Square root of 0.5 is 0.707. Then 0.866. And finally, square root of 1 is 1. So the area is the base times the height. So 0.25 times 0.5, which I can kind of cheat and look up here and see that's 0.125. And then 0.25 times 0.707, that's 0.177. Then 0.25 times 0.866. You've already done the work. It's up here. That's 0.217. And finally, 0.25 times 1. Don't need a calculator for that. That's 0.25. So we add those up to get our upper sum, our right-hand sum, which is just the estimate of the area using this method. And it's going to be bigger. It's 0.768. All right, so you can see, and the reason it's bigger is you can see if you use the left-hand sum, then you've got the purple here, and it shortchanges the actual area right under the curve because you're missing these values here. And then if you do the right-hand sum, you've got extra, which is in blue, which is above the curve. So really a better method would be to use the average of the two, what's called a middle sum. All right. So that does it for 35. Now let's look at 37. So 37, we have y equals 1 over x. So that's what we'll be using to determine our height. And looking at this one, we've got 5 rectangles to deal with. And so you would have the base of each rectangle is between 1 and 2 would be 0.2. All right, and so the height, our first x is 1, our second is 1.2, our third would be 1.4. Then, as you go down, so you just add 2 to each one until you finally get to 2, starting at 1 and going to 2. Okay, so if we use a left sum on this, so first of all, let's do the lower. And this time, since it's a decreasing function, your left sum will be greater than your right sum. So make a little chart, rectangle, 1, 2, 3, 4, 5. our base for each rectangle is 0.2. Our height for each rectangle, okay, so it's 1 over x. Well, if we're using the left sum, right, that's 1 over 1. Our first x is 1. Our second would be 1.2. Our third would be 1.4, and we'd end up at 1.8. So it's, I'm going to have to go sideways here, but it'd be 1 over 1, which is 1. So I'm just plugging into this equation. Our second is 1 over 1.2. All right, 1 over 1.2 would be, let's see, .833, and then we would have 1 over 1.4, which is 0.714, 1 over 1.6. So we're just getting the y values of this, the left sides of these. And that is 0.625. And finally, 1 over 1.8, which is 0.556 is what we'll round that to. So then our area of rectangle 1 would be 0.2 times the height of 1, which is 0.2, and then 0.2 times 0.833, base times height, which is 0.167, then 0.2 times 0.714, which is 0.1428, then 0.2 times 0.625, and we'll save a lot of time on the next sum because we'll have all this done, which is 0.125, and then finally 0.2 times 0.556, and that's 0.111. And you add those 5 rectangles up, and you get 0.7458. All right. And so let's take a look at the upper sum. So we do the same thing. The base of each is 0.2. The height. Now this time we're starting on the right hand sum So we are starting on the right rectangle, which would be 1.2, and then we'll go to 1.4, 1.6, 1.8, and then finally 2. All right, so we would have 1 over 1.2, and 1 over 1.4, 1 over 1.6, 1 over 1.8, 1 over 2. All right, so 1 over 1.2 is 0.833, and we would have 0.714, 0.625, 0.556, and finally 0.5. So the area is 0.2 times 0.833, which we know is 0.167. Then 0.2 times 0.714, which is 0.1428. And 0.2 times 0.625, which is 0.125. And 0.2 times 0.556, which is 0.111. And finally 0.2 times 0.5, which would be 0.1. So we're going to add those values up. So that's 0.167 plus 0.1428 plus 0.125 plus 0.111 plus 0.1. And it should be less than 0.7458. It's 0.6458. All right, so that would be the left-hand sum, and this is the right-hand sum, and that's an estimate of the area using rectangles. Whether you use a left-hand sum that overestimates the area, and this one, and right-hand sum underestimates the area because it's a declining function. It was opposite that on number 35. All right, so that does it for this solutions video. I know those two rectangle problems are tedious, but it explains how to do it. And I'll talk to you next video.